Okay, so let's fill in this first blank. So it says, like we did in chapter 2, we need to get the variable by what? Good. So that should say itself. And then, now remember, we're kind of doing this. I mean, I know some of these you have to combine like terms first, or you have to do the distributed property first. But in general, we're trying to do the order of operations backwards. So what will we do first then? Hold on 1 second. Mr. Z? What's up? Okay, what's up? Yeah. Okay. Okay, gotcha. All right, thanks. Bye. Okay, so let's see, what do we got here? So if we're doing order of operations in reverse, like what was the last thing you normally do in order of operations? Addition and subtraction, yeah. So we're actually going to do those first. So I know some of these you got to, like I said, you got to combine like terms or do the distributed property first. But in general, we're going to say we're going to undo addition and subtraction first. So this blank should say addition and subtraction. All right, and then what about, what would you undo next then? Go ahead, Dewan, say it again. Yeah, multiplication and division. So then we would undo the multiplication or division. It's supposed to be an M right there. All right, and then we just go right into the examples. Now there is a little comment, but again, I said that many times when we were going over the homework from yesterday, is that it says, remember, if you divide or multiply both sides of an inequality by a negative number, then you got to flip the inequality symbol in the middle. So we got to remember that as we do these. So let's do the first two. All right, so number one, let's see, let's call on some people here. So you guys, what would you do first? Raise your hand. Dewan? What's that? I still can't hear you with it. I got the fan on behind me. Excellent, yeah. Yep, subtract 45 on both sides. So we're going to subtract 45 on both sides, which follows that blanks we just filled in, right? We said first we're going to try to undo the addition or subtraction. So then these would cancel out on the left side, make 0. So then on the left side, we've got 2b on the left side. On the right side, we got 61 minus 45, that's 16. Do I need to flip it? No. No, flipping is only if you're multiplying or dividing both sides by a negative. So it was a greater than, so it's still a greater than. And then I finish by, again, somebody raise their hand, give me the next step. Rachel?
Divide by 2.
Yep, divide both sides by 2. That's the number in front of the variable. Those will cancel out and make a 1. So I get B is, well, do I got to flip it? No, because I divided by a positive. I only flip it if I divide by a negative. So I get 8 on the right-hand side, and I still got a greater than symbol here. All right, now we need to graph this thing, so we're going to put 8 on our number line. And then, is this going to be open or closed dot? Yeah, there's no equal to bar, so it's open. So we got an open dot at 8. Shaded which way? Right, good. There you go, so there's the first one. Again, raise your hand, just don't blurt it out. Who's got a first step for me on number 2? Aiden, that phone's going into jail. All right? Yeah, go ahead. Okay. Good. Yep, subtract 8 on both sides. Those cancel on the left and make 0. Don't forget to bring down the negative in front of that 3, so it's a negative 3y is greater than or equal to 29 minus 8 is 21. And then who's got the next step for me? Again, raise your hand, don't blurt it out. Go ahead. Good. So divide both sides by negative 3. And then, Jonathan, do I got to flip it or no? Yeah. Good. Yeah, so those negative 3's cancel on the left-hand side, make 1. The right side, I've got 21 divided by negative 3 is negative 7. But yeah, I've got to flip it because I divided both sides by a negative. So it was a greater than or equal to, so now it's a less than or equal to. And then all we need is negative 7 on our number line. And then you guys tell me, is this open dot or closed dot? Closed. Yep, it's closed. And then shaded which way? Correct. That's good. Yeah, those are definitely, the shaded region is definitely the numbers that are less than negative 7. They would be to the left of negative 7. All right, let's do number 3. So the first thing, somebody raise your hand. What do I got on the left-hand side? What's 2 minus negative 10? Jonathan, you got it again? Yeah, you got to add 10. Yeah, so that's actually, when you see it, when you subtract a negative, that actually means you got to add. So that's 2 plus 10. Okay, so 2 plus 10, that's just 12. So then someone else, what's the last step on this one then? Aiden? By what? 4. What kind of 4?
Negative 4.
Thank you. That's good. So divide both sides by the number out in front of the variable, which is a negative 4 in this case. The negative 4s over there on the right cancel out and make a 1. On the left-hand side, I've got 12 divided by negative 4, that's negative 3. On the right-hand side, I've just got t. But then the question is, do I need to flip it? Yeah. Yep, I got to flip it. It was a greater than, so now it's a less than. Now, again, this is one of the ones, again, where you just want to, I'm going to rewrite this, okay? So when I rewrite this thing, I like to write it with the variable on the left-hand side. So these are equivalent. I'm going to put the t on the left-hand side, and I'm going to put the negative 3 on the right-hand side. What do I put the symbol pointing towards? Yeah. Which way do I put it in there? Pointing towards what? Go on. Say it again. Good. Yep. Yeah, over here, if you look at it, it's pointing towards the negative 3. So that means when I write it over here, I want it pointing towards the negative 3. So it's going to be like this. And then some people that was bothering some of the kids in the 7-8 block when I kept doing that. These are equivalent, okay? To say that negative 3 is less than t, that's exactly the same thing as saying t is greater than negative 3. And so let me just write this real quick, just with numbers. So like if I told you that 3 was less than 10, that's the same thing as saying 10 is greater than 3, correct? Yeah, those are the same thing. 3 is less than 10 is exactly the same thing as saying 10 is greater than 3. In fact, if you kind of just take this one right here, if you just kind of read that backwards and read it in this direction, going from right to left, it says 10 is greater than 3. So that's kind of what I did to get this answer right here. But anyways, we got to graph this thing. So we got to put negative 3 on our number line. And then open circle or closed? Yep, it's open. There's no equal to bar, so it's open. And then which way do I shade it? Yep, it's to the right. Those are definitely all the t values that would be greater than -3. They would be to the right of -3. What's up, Colton?
My mom said she go down to the office for me to go home.
What's that?
She go down to the office for me to go home.
But usually they'll bring me a pass, though.
You know, she just called because she had just texted me and told me that she called.
Well, I still gotta wait for a pass to come up here. A runner will come up here with a little pass for you to go, like a little slip, all right? So just hang on until they come up here. And then, where am I at here? Is she here yet or no? She's there at the office or no?
No,
Well,
she called.
Well, how are you gonna get home?
Like,
You got your bike? But I still gotta wait for a pass to come up. Or the office will call me and tell me that, that you got a pass. But let me keep going here and then I'll call down there and see what's up. All right, so we're on number 4. So number 4, who's got a first step for me on this one? Damien?
Distribute the -4.
Good, yeah. We're going to distribute the -4. So remember there's a multiplication in here, right there. And we're going to multiply the -4 times the 2, and we're going to multiply the -4 times the -x. So let's see. So we've got -4 times +2. Good, -8. And then we got -4 times -x. Go on. What's that? What's a negative times a negative? You see that? It's a -4 times a -x. So a negative times a negative is going to be a positive. So we're going to write a plus here then. That addition symbol, that implies that 4x is going to be positive. And then that's less than or equal to 8. All right. Then we're going to add 8 on both sides. Again, because we want these 8s over here to cancel out and make 0. So now we got a positive 4x is less than or equal to 16. Then we're going to divide both sides by the number out in front of the variable. On the left, I get x. On the right, I got 4. Do I need to flip it? No. I divided by a positive, so I leave it the same way. So it was a less than or equal to, so I leave it as a less than or equal to. And then, so then I got to put 4 on my number line. And then is that open or closed? Yeah, it's closed because of that equal to bar right there. So we got a closed circle and shaded which way? Left. All right. Let's do 5. 5's got a bunch of fractions in there. So let's try that. So number 5. The first thing I'm going to do is I'm going to subtract 1/2 on both sides. So I want to subtract 1/2 on the left, subtract 1/2 on the right. All right, so let's kind of work this out on the side over here real quick. So I've got to do 1/3. 1/3 take away 1/2. So in order to add or subtract fractions, I got to have a common denominator. So what's the common denominator for 3 and 2? Yeah, that's 6. So I want to make both of those denominators into a 6. Well, in order to do that, I'm going to multiply this fraction by 2/2. Now that denominator will be a 6. And then the other fraction, I'm going to need to multiply by 3/3. And now that denominator will be a 6. So if you multiply straight across the top and straight across the bottom, or straight across the numerators, straight across the denominators, on the left here I'd have 2 times 1, so that's 2/6. And then the one on the right there, if I do 1 times 3, that's going to give me 3/6. So then I know that I'm going to keep my common denominator of 6, and then what's 2 minus 3? What kind of 1?
Negative.
Yeah, negative 1. Okay, so that's kind of all on the side. All I did right there is I just took care of this part right here. I just did that. I just did 1/3, take away 1/2. So then, let me write the rest of this. Well, again, we can see right here that these cancel out, right? 1/2 minus 1/2, that's 0. So then all I got on the left-hand side now is 2/3 f. So 2/3 times f equals that fraction I got on the right, which was that negative 1/6 that I got right here. Okay, so then to finish this up, how do I get rid of that 2/3 in front of the f? Anybody got an idea on that? Yeah, but what do I got to do that? Damien, you got it? What do I do?
You divide the 2 and the 6 by 2. By cross.
Well, you can't really, we got that variable in the way there, so you really can't cross cancel at this point. Dewan, what do you got? What's that? You could divide. You could divide both sides by 2/3. That would work. You'd have to do negative 1/6 divided by 2/3, which means you'd have to work with some fractions. But what's the other way that we do? Yeah. Yeah, multiply by the reciprocal. Let's do that instead. I mean, it will work. If you divide both sides by 2/3, that'll work out. But let's multiply by the reciprocal of that number in front of the f. So we're going to multiply the left side by 3/2. That's the reciprocal of the 2/3. And we're going to multiply the right side by 3/2. All right, so then these 3's will cancel, these 2's will cancel, so I'll end up with just 1f on the left-hand side. And by the way, I put an equal sign in the middle there for some reason. That's not correct. It was supposed to be that's a greater than, right? So I was supposed to bring down the greater than symbol. Okay, so anyways, on the left-hand side, we have just 1f now is greater than, and then we could just multiply straight across the top and straight across the bottom. Or if we cross cancel first, 3 divided by 3 is what? That's a 1, and 6 divided by 3 is a 2. So now if we multiply straight across the numerators, we get negative 1 times 1. That's negative 1. And then we multiply straight across the denominators. That's 2 times 2 is 4. So we end up with f is greater than negative 1/4. All right, so let's graph that on our number line. Now in the book, they'd probably get fancy on this and they'd like call this 0, and then they'd do like, they'd call this negative 1, and then they'd say negative 1/4 is like right there. But we're not going to do all that. We're just going to put negative 1/4 on our number line. So we'll put negative 1/4 right here. So there's negative 1/4. And we're just going to say open circle or closed. Good, it's open. And then shade it which way? What's that?
Right.
Yeah, to the right. All right, we got 2 more to go. You guys good with that one? Yeah, all this over here was like work to the side that we did. All right, let's do 6. So 6. What can we do first on 6? Damien, what you got?
Combined like terms.
Perfect, yeah, combine like terms. Yeah, we can combine these two. We got 8x, take away 5x. So how many x's do we got then?
3.
Yep, 3 x's. So that's going to give us 3 x's on the left-hand side. And then minus 21. And then that's going to be less than negative 15. All right, so then we're just down to a two-step inequality again. So we're going to add 21 on both sides. And that's going to, the 21s are going to, or the negative 21 plus 21, that's 0, that cancels out. So then I just got 3x on the left side, and on the right I got 6. And it's still a less than. And then I just divide both sides by the number out in front of the variable. And these 3's cancel out and make a 1, so I get 1x is less than 2. And then we just got to graph that. So we'll put 2 on our number line. And then open or close circle. It's open again because it does not have the equal to bar. So open. And then it's a less than, so we're going to go which way? Yes, to the left. The numbers that are less than 2 would be to the left of 2 on the number line. All right, we got 1 to go. There's 1 on the next page. That's a word problem one, right? All right, let's do the word problem. You don't like words? All right, let's try this. Okay. This says you want to go to the car rental place. You're trying to figure, you're going to rent the car for just one day, okay? You're trying to figure out if it would be cheaper to go to rent a car or to Enterprise. All right, so rent a car just charges you, right here, rent a car just charges you $55 for the day. That's just a flat fee, just $55. But then Enterprise, they charge you, where is it here? They charge you $38 per day, so they charge you $38 up front, plus they charge you 20 cents per mile. So what do you do when you see that word per? Does that mean add, subtract, multiply, or divide? Yeah, it's multiply. If it's 20 cents per mile, that's 20 cents for each mile or 20 cents for every mile. So that's going to be, we're going to call the number of miles, we're going to call that M. So let's write this out like this. So for Enterprise, so let's write Enterprise here. Okay, so for Enterprise, it's $38 up front, plus it's 20 cents. It's 20 cents per mile. So we're going to do 20 times M. Where again, M there represents the number of miles. All right. And then for the other one, rent a car. So for rent a car, they just charge you $55. That's it. Now, it's a little bit confusing in this one because you see the word per up here also, right? $55 per day, and you also see it here, $38 per day. But again, we're just renting the car for one day, all right? And we're trying to figure out which one would be cheaper. So, and then the question here says, how many miles does it take for rent a car to be less than Enterprise? So we want rent a car less than. That's the key thing right there, right? Maybe I should do this in a different color here. Maybe, let's go with this color. So we want rent a car less than Enterprise. So hopefully that doesn't show up very well, does it? Hopefully you guys can see that. We want rent a car less than Enterprise. So which way so this is really my inequality that I've been writing right here, okay, this thing. So all I got to do is figure out in this gap in the middle right here, do I put a less than or a greater than? So which way do I want it pointing if I want rent a car to be less? This would be, here, that would be case 1 there. There's case 2. Which one would it be? Do I use 1 or 2?
1. 2.
I want rent a car to be less.
2.
Yeah, Colton, that's good.
2.
Yeah, definitely. Yeah, it goes this way. It goes that way. We want rent-a-car to be less, so you always put it pointing at the smaller one, right, or the one that's less. Almost. So then, let's solve this thing. So we got to solve it. So to solve it, we are gonna subtract 38 on both sides. And so then they're gonna the 38s are gonna cancel over there on the left. So then let me come over here. So then what I have is, on the left-hand side, I just have 0.20 times m is greater than 55 minus 38. What's that, 17? Then we're just going to divide both sides by the number in front of the variable, which is just 0.2. And then those are going to cancel out over here and make a 1. So I get m is greater than,
85.
good. And I'll put miles on there. So that's your solution right there. You don't have to graph it. What does that mean? That means that this one right here, rent-a-car, will be cheaper when you're going to drive more than or greater than 85 miles. So if you know you're going less than 85 miles, you're going to want to rent from Enterprise. Okay? Does that make sense? So let me say it again. So if you're going to go less than 85 miles, you're going to stick with Enterprise. But if you're going to go more than 85 miles, yeah, if you're going to go, well, I should say, I guess, if you're going to go less than or equal to 85 miles, well, at 85 miles, they'd be equal to each other.
Yeah.
So if you're going to go less than 85 miles, you're going to want to go with Enterprise. If you're going to go more than 85 miles, you're going to want to go with a rent-a-car.
You're just on 55 minus 38, which would be 17, 17.
Times 5. Yeah, because when you divide by 0.2, 0.2 is 2/10, which is the same thing as 1/5.